Hey guys, I would like to explain this number 14. Hopefully it helps you understand what this question is asking. So in number 14, here's what we know. We know if P is a prime in this sequence, then this P will be also in this sequence. That's what you want to show. In other words, if you look at the sequence of the first one, say this sequence is 4, the next one is 7, the next one is 10, the next one is 13, and so on and so forth, right? So all these numbers look like this type of number. It's from 3n plus 1. From this sequence, there are a few primes. For instance, this is a prime. This is a prime. We just want to show that these primes also in the sequence of this guy 6, like in this sequence you have when n is 1, this is 7, when n is 13, when n is 3, this is 19, and so on and so forth, right? The question is, whenever you have a prime in this sequence, you want to show that it's also in this sequence. That's what it is. Now, the way that you guys interpret it is want to find the values for n which this guy results a prime number. Actually, we don't care about those values. We just want to say if there's a prime in this sequence, it should be also in this sequence. And what is this sequence? All the numbers in this sequence looks like 6k plus 1. So here's what I would do. Here's my suggestion. Here say suppose K like P is from this sequence, which basically means it can be written as is from this sequence, right? Is from this sequence, 3m plus 1 sequence. In other words, P should be equal to 3 times some integer, let's call it, say, n, right? Well, we use n here, maybe we'll just say k here, right? 3k plus 1. Now you want to show P can be written as 6 times some integer plus 1. That's basically what you want to show, so that any prime in this form, it can be written into this form. And I do like that you discuss odd and even, because now you can discuss two cases, right? When k is odd, that's impossible. I do see that you guys mentioned that that's impossible. Possible because that would not give you a prime, so therefore it cannot be, k cannot be odd. If it is odd, 3 times odd will be odd. Odd plus 1 is even, so P cannot be prime. And then when k is even, which means k is, say, 2 r sum r, right? And then you want to do a little algebra so that you plug in here, show P can be written into this form. That's what you want to show.